Article 314.16 FIV addresses equipment grounding conductors and box fill calculations. However, the rule changes when dealing with isolated grounds. An isolated ground is not counted for box fill calculations. The reason for this exclusion lies in a fundamental difference in how an isolated ground functions compared to a standard equipment grounding conductor. In a typical electrical system, the equipment grounding conductor provides a path for fault current to return to the source, tripping the overcurrent protective device such as a circuit breaker or fuse. It is connected to the neutral conductor at the service entrance, creating a low impedance path. Because it is part of the fault current pathway, the standard equipment grounding conductor is counted towards the box fill to ensure there is adequate space for conductors to dissipate heat and to prevent overcrowding, which could lead to installation damage and potential electrical hazards. An isolated ground, on the other hand, is specifically designed to prevent the flow of normal or fault current. It serves as a dedicated grounding path for sensitive electronic equipment, minimizing electrical noise and interference. The key characteristic of an isolated ground is that it is not connected to the neutral conductor or any other grounded conductor within the panel board or distribution equipment. Instead, it runs directly from the equipment being served back to the grounding electrode system, typically at the service entrance, without any intermediate connections. Because the isolated ground is not intended to carry current under normal or fault conditions, it does not contribute to the heat generated within the electrical box. Therefore, it is not required to be counted when calculating box fill. It is important to correctly identify an isolated ground. It is typically identified by an orange color or an orange stripe. This visual cue helps electricians and inspectors distinguish it from standard equipment grounding conductors. The proper installation of an isolated ground is crucial for its effectiveness. It must be installed in accordance with the National Electrical Code, specifically Article 250, which covers grounding and bonding requirements. The isolated ground conductor must be properly sized based on the size of the ungrounded conductors supplying the equipment it serves. It must also be connected to the grounding electrode system at the service entrance using approved methods and connectors. When performing box fill calculations, it is essential to understand the different types of conductors and their respective counting rules. Article 314.16 provides detailed guidelines on how to calculate box fill, including the number of conductors, device yokes, and equipment grounding conductors that must be counted. Failing to accurately calculate box fill can result in code violations, overheating, and potentially dangerous electrical conditions. To recap, the main distinction between a standard equipment grounding conductor and an isolated ground conductor lies in their function and how they are connected within the electrical system. The standard equipment grounding conductor serves as a fault current pathway and is connected to the neutral conductor, while the isolated ground conductor is a dedicated grounding path for sensitive electronic equipment and is not connected to the neutral conductor. This difference in function justifies the exclusion of isolated ground conductors from box fill calculations. Firstly, understand the role of the equipment grounding conductor in a standard electrical system. Secondly, recognize the distinct purpose and configuration of an isolated ground. Thirdly, adhere to the National Electrical Code guidelines for grounding and bonding. The National Electrical Code is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. It is essential for electricians, electrical contractors, and inspectors to stay up to date on the latest edition of the NEC to ensure compliance and safety. The NEC provides detailed requirements for grounding and bonding, including conductor sizing, installation methods, and connection requirements. It also covers specific requirements for isolated ground systems, including the identification, installation, and testing of isolated ground conductors. By following the NEC guidelines, electrical professionals can ensure that electrical systems are installed safely and reliably. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to check with the local authority having jurisdiction to determine if there are any additional requirements that must be met. Understanding the differences between standard equipment grounding conductors and isolated ground conductors is crucial for accurate box fill calculations and safe electrical installations. By following the NEC guidelines and local codes, electrical professionals can ensure that electrical systems are properly grounded and bonded, minimizing the risk of electrical shock and fire hazards. Remember, the isolated ground is not connected to the neutral or any other grounded conductor, therefore it does not carry current under normal conditions and is not counted for box fill. Accurate box fill calculations are important to ensure the safety and reliability of electrical systems. Overfilled boxes can lead to overheating, insulation damage, and potential fire hazards. By following the NEC guidelines and best practices, electrical professionals can ensure that electrical boxes are properly sized and filled, minimizing the risk of electrical problems. Also note, an overfilled electrical box can prevent proper heat dissipation, potentially leading to premature failure of conductors and devices. Proper conductor bending space within the box is also essential for safe and reliable connections. The NEC provides specific requirements for conductor bending space based on the size of the conductors and the type of enclosure. Ensure that the isolated ground conductor is properly sized and connected to the grounding electrode system. Use approved connectors and methods for making connections. Also ensure that the isolated ground conductor is properly identified with an orange color or stripe. This will help prevent confusion with standard equipment grounding conductors. Finally, remember to consult the latest edition of the National Electrical Code and local codes for specific requirements and guidance.